This video will be about even and odd functions, particularly with trigonometric functions. So first we need to just discuss what is an even function, what is an odd function, what is neither. So an even function is symmetric about the y-axis. A good example of that is a quadratic. Basically, you could fold it in half across the y-axis and it would match. Now, if it was off the y-axis, yes, I can fold the black one in half, but not across the y-axis. So this one is not even. So we can find it graphically pretty easy. Just look at it and say, would it fold in half? If we had to do it algebraically, you're going to have to plug in negative x into the function. If you plug in negative x, but when you simplify everything, it comes out with what you had originally, it's even. So f of negative x equals f of x if a function is even. It's easier with just, again, like the quadratic, so we're going to check f of x equal to x squared, just to show a quick example. If I plug in negative x squared is the same thing as negative x times negative x, or positive x squared. So what we started with, x squared, matched what we ended with. Those were the same, therefore our function is even. An odd function is symmetric about the origin. A good example of an odd function is x cubed. Basically what we're saying is you could take just the left side and rotate it 180 degrees to get the other piece. If we took, let's see if I can do this, if we took this black piece and rotated it 180 degrees, and it would rotate about the origin. Obviously my picture is not the best because they're not matching exactly, but hopefully you get the idea. They should match exactly if I had drawn the graph exactly correct. So an odd function, like an even, you've got to plug in negative x to check it. I'm going to erase some of this so I can have some space below the odd. So with our odd function, we're still plugging in negative x, but this time, instead of coming out the same, it should come out with everything negative. So f of x, if that's x cubed, again, we're going to check it. If we plug in negative x to the third is the same as negative x times negative x times negative x, which would be negative x to the third. So we took what we had originally, and the only thing we changed about it was that there was a negative sign in front. So for a function to be neither, so we said a quadratic works as long as it's on the y-axis. If it was off, it didn't work. So one of those would be neither. So let's say we have x minus 3 squared. We would then check this by still plugging in negative x. So if we plug in negative x, we get negative x minus 3 squared. On this, since they're both negatives, we can factor out a negative 1. Oops, sorry, I did not mean to move where the video was showing. So inside I could factor out a negative 1, which gives me x plus 3. Both of those divide by negative 1. It's x plus 3, all squared. We can distribute the squared to each of them. So we have negative 1 squared times x plus 3 squared, which would be negative 1 squared is positive 1, so it would be x plus 3 squared. So our beginning was x minus 3 squared, our end is x plus 3 squared. Definitely didn't stay the same. We went from a minus in the middle to a plus. And then if it was going to be an odd function, we would have to take this whole thing and just put a negative sign in front of the entire thing, which obviously we did not do. So this one would be neither. So now let's talk about our trig functions. What happens when we're working with trig functions and trying to decide if they're odd or even. So first, for trig functions, you need a lot of formulas. There's a page called SOS Math where they have a list of the trigonometric identities. And it has a whole bunch specifically for our needs right now. We want to use just the even and odd identities. So sine of negative, they use u instead of x. Sine of negative u equals negative sine u. That means sine is odd. It came out negative. Cosine of negative x is cosine x. That one would be even. And so would the one below it. So for sine and cosecant, those are both odd. For cosine and secant, those are both even. And for tangent and cotangent, those are both odd. So you will need those formulas as you go through these kinds of problems. So now let's try some. So let's say we want to check cosine of negative x minus sine of negative x. And we want to decide what will this come out to be. So now we're just going to be using those formulas. Cosine we said was even, so cosine of negative x is just cosine of x. Sine of negative x was negative sine of x. So we get cosine x plus sine x. So that one we just simplified. If we want to actually check and see if something is odd or even, say we have f of x is x squared times sine x times cosine x. This time we have to plug in negative x ourselves. So we would have f of negative x equals, everywhere we see an x we replace with negative x. I always write it in parentheses, especially when you have an exponent, just to make sure I don't make any sign issues, which is very important in this one. We're very, very concerned that we put in the correct signs. Sorry, we're also replacing that x with a negative x. Cosine of negative x. So negative x squared. In our first examples where we were just looking at quadratics and cubics, we know that that came out to be positive. So negative x squared comes out as just x squared. Sine of negative x, we go refer to our formula. That comes out as negative sine of positive x. Cosine of negative x comes out to be cosine of positive x, according to our formula again. So all together, this entire thing, since we have negative sine, this entire thing would be negative x squared sine x cosine x. So looking at what we had originally, it matches everywhere except now we have a negative sign in front. That means our function is odd. So this would be an odd function. If it had matched exactly, it would be an even function. And that's how you check every function to see if it's odd or even. You plug in a negative x and simplify it. Let's do one more example, though, that can be a little more difficult. Let's say f of x is x minus 5 squared times sine squared of x over secant squared of x. So with this one, we still plug in negative x. That beginning part will never change. I'm going to plug in negative x. So with our parentheses again, we want to factor out a negative 1, like I showed you again in one of those beginning examples. So we'd have negative 1 squared times positive x plus 5, all squared, sine squared of negative x. We're going to focus on the sine of negative x part, which we know comes out as negative sine x. Now since it's squared, with trig functions, when we're using exponents, it's easier to put parentheses around the whole thing and write it on the outside. The reason mathematicians don't usually do that is because you could assume just the x is squared, but that's why we have parentheses around the whole thing. And the reason we do that is because now when we rewrite sine of negative x as negative sine x, we can see we're squaring this whole thing, and we know a negative times a negative will come out positive. So this piece will come out positive sine squared x. Same thing with secant. I'm going to rewrite the whole thing as that trig function squared. Secant comes out as positive secant x, and that whole thing's squared again. So now we simplify even further. Negative 1 squared is positive 1 times x plus 5 squared. Negative times a negative made that positive sine squared x. Secant squared would just end up being secant squared. We didn't have to worry about the sign since it was already positive. So now we have to compare it to the beginning, which was x minus 5 squared sine squared over secant squared. So a lot of stuff matches. Secant squared matches, sine squared matches, which might lead us to believe it's even if we're not looking closely. What doesn't match is this is a positive and this is a negative. So since it didn't change to be negative in front of the whole thing, it just changed a negative sign in the middle of the problem, this is a neither answer. It is neither even or odd. It didn't come out exactly the same. It didn't come out, so the simplified answer was negative of everything we started with. So it is a neither.